The Internet of Things is growing fast, but new connections bring new challenges: security, scalability, control. How do you get the best from IoT in the cloud without exposing your data and devices to the worst? Soracom is purpose-built for IoT, with affordable global connectivity and secure cloud integration to let you control, scale, connect, and protect your IoT network. From startup to enterprise, across industries and around the world, you create, we connect.
Hey, welcome to another Soracom live stream. We're here today to talk about the nRF9160 Feather IoT Development Board by Circuit Dojo. This board is pretty amazing. Excuse me. We're excited because now when you buy one, you'll also get in Soracom Global IoT SIM card and $10 credit. So you can get started building awesome projects that use LTE connection. You can make GPS asset trackers and all sorts of awesome remote devices. And to talk with us about this is the creator, Jared Wolff. So I'd like to welcome him. Hi, Jared. How are you doing today?
Hey, Mohib. Good. How are you?
Not bad, not bad. I'm excited. We were chatting a bit before the stream started about some of our awesome tools, but I gotta ask, man, like how did you end up going into this project? Like what inspired you to create this? Because you built this all on your own, right?
Yep. Yeah, designed it on my own. This was what, like last year time, but just around this time, I think it was like April. I was kind of looking for some inspiration. My contracting work was kind of slowing down. I was like, oh, why don't I just work on something cool? So I started with a different cellular module that I knew that was fairly popular. And I was like, oh, why don't I just make a feather wing of it? And then just the assembly process was terrible. I screwed it up the first time around. I was like, all right, let me try something else. So I had been paying attention to Nordic and what they were doing with cellular. I've been a longtime developer on their silicon, all the way back to the nRF91, actually the nRF, 8001, which is just their standalone BLE device. And I was like, all right, I'm just going to watch this and like see when this really is interesting. And it just happened to be really good timing. They were just kind of getting to their 1.0, 1.1, they're just like, things are looking, you can see that their marketing is starting to ramp up. I think it's like, all right, they're confident on this thing. So I was like, why not? So I started looking into it. Didn't really see much out there in terms of what was available. And I did search on DigiKey, like nothing except for their DKs. Like, oh, wow. So ended up building this guy, designing it kind of from scratch, using the Feather form factor, just adding the features that I thought would be useful for folks, including like an onboard flash, battery charger, USB to serial UART, because unfortunately the nRF91 doesn't have a USB PHY, and obviously UFL connections for both GPS and LTE.
Yeah, it's an amazing board. I've been tinkering with it. I actually got an example working with Soracom the other day, the MQTT simple example.
Yep.
I was able to modify it a bit, and it's such a perfect form factor.
Yeah.
The Feather. For those who are watching and aren't familiar, the Feather formats was Adafruit came up with it, right? This idea of like here's a stack, in the same way that Arduino has their standard header stack. You can do the same with these. There's a bunch of modules, and I'm assuming the pinout matches. If you were to get any Feather module, would it be compatible?
Yeah.
With the pinning?
There are some like slight differences. So originally I was kind of using Particle as an inspiration from their pinout. I think they use it slightly differently than what Adafruit had, because they had like the mode pin, and they also, I think, weren't connecting this guy on the end here. So in this guy, it's a multi-purpose. I just added as much as I could. And then there are some, if you look carefully, there are some jumpers on the back here, so you can actually modify the board to however you want. And that allows you to actually use more GPIOs. So But yeah, if you get a feather wing of any kind, it should work as long as you're not using the hardware bits somewhere else, like the peripherals, UART, SPI, I2C.
That's cool. I love every time I look at this or when you mention stuff, I'm like, oh, I didn't even notice that. Like
Yeah.
there's all these like little hidden things on this board. Because it looks simple off the bat, right? But I imagine there's a lot of love and blood, sweat, and tears that went into this. So, what did you use to design the board?
So I used Eagle. Been a pretty avid Eagle user ever since my very early days in designing electronics. Mostly because it was all the inspiration from folks like SparkFun and Adafruit. They were all using Eagle. I've used every CAD package under the sun, but Eagle is just easy to go to.
Yeah, it's so, and I love the board color. Was that on purpose or was that just the
That
manufacturer?
was that. So originally it was black. I don't know if you see the first version and the second version were black. And the pictures you see here is actually the prototype that I hand built myself.
Oh, nice.
So that was like the latest version at the time. I used Osage Park and I just kind of built it up. But yeah, they're black. And then we were having so many issues with the solder mask because I thought solder mask was too thick in production. So I was like, all right, well, I pulled my customers on it. I said, hey, like, what colors do you want? So black was first, and then transparent solder mask was second. So I was like, this is interesting. Why not? So it's transparent. That's the actual color of the copper when it's not plated.
That's beautiful. Yeah, it's just it reminds me a little of the orange crab if you've seen that board.
Yep.
It's got this, yeah, and you gotta love that, right? Like it's always been interesting to me in our world, right? Like the hardware world, that there's now this interest in aesthetic, right? Because if you remember like the old dev kits or some of the ones that even Nordic's dev kits they put out, they're still very much like, here's a big old rectangle and
yeah, it was exactly that.
Have fun. Yeah. And I'm like, just give me the chip, some pins, and I'll figure out the rest, right?
Right.
Yeah, I was impressed too. The documentation's pretty thorough. I gotta say, so it sounds like there was quite a bit of hacking involved with getting it to work with the NRF tools. So,
Yeah.
right, it uses the NRF Connect, and I saw that you had to create kind of a hacked version of the LTE link monitor, and there was a couple of little things I had to do, yeah, for the SDK setup. But once I got it going, I was actually pretty impressed with how well it compiled and flashed. I got like a little nervous at first because I was like, it's been a while since I've done something outside of the Arduino IDE. I've been spoiled, but
yeah,
real
so
impressed with it.
Early on, it was really painful. So the instructions before this, I removed them just so it just doesn't confuse people. But the original instructions were very like step by step. If you do this wrong, you will screw things up, and inevitably reach out to me and be like, "What's wrong? I can't fix this." But now Nordic has made this super easy. They spent a lot of dev hours just making it so you can download the SDK in one package, very similar to their previous SDK, which you basically just download it in one package and you're done. So you download it in one package, it'll install it for you, and then it's just a matter of changing a couple of environment variables, and that's it.
All right. Yeah, it's cool too. There's I was impressed that there's the all the different tools that come with NRF Connect, right? Like, let's see, that's the wrong one. Or open this up again. If it's gonna be compliant here. Yeah, just for those that are watching.
Yeah, so this is a really
a bunch of tools.
excellent program. If you're doing any Bluetooth work or LTE work, they've put everything in one place.
Yeah, just like this. I haven't installed the version that works with this board, but I just love this idea of just here's a console to do all your AT commands, visualize things, signal strength. It's all built.
You can actually use that. You can use that with the nRF9160 feather.
Yeah, and there's you have to install a kind of modified version though, right?
Nope. I
Oh,
did a
okay.
PR and it's all rolled in. So there's the checkbox that I added is in there, which is kind of cool.
Oh, nice. And so this would just be I installed the AT client firmware.
Yep.
On the
Yeah,
chip.
the AT client or the I think there's another LTE connectivity one that essentially is the AT client with a lot of extra features.
Oh, very cool. Yeah, that's let's pull it up here. Also, it was funny. So getting used to this at first, I did get worried I was going to brick my board because there's a flag you have to put in about MCU boot, right, in one of the config files so that it creates the app update binary.
Yep, correct.
And I didn't have that at first when I was modifying the MQTT sample. And my brain was like, oh, there's a Zephyr.binary. I'll just flash that. And it flashed. And I was like, wait, this seems like I wasn't supposed to put this on there. And it didn't break anything, which is nice. But there it goes.
Yeah, you don't have to worry about that. I think MCU boot is pretty bulletproof from that perspective. You should be able to load something wrong in there. It shouldn't take it. So
yeah. So yeah, these are the examples that are specific to this device, right? These we have the AT client.
So a lot of them are reused from the nRF Connect SDK or from Zephyr. So what I've done is I've imported them, or I'm actually referencing them in the SDK, and then I've just modified them slightly. So you were referring to the MCU boot flag, like the enable flag for that. Like all of that is added. So all you have to do is just like compile it and it works, instead of having to edit to project files or edit an overlay file or anything like that. It's all done for you.
Yeah, it's pretty cool how well it builds to. I think you just do west build, right, and then west build. Oh, there's a specific command.
Yep,
that's right.
There you go.
Got to do that. Yeah, so just running that command, and this is a clean build with the -p flag.
Yeah,
it just works so well. Tell me more about Zephyr. So I wasn't super familiar with Zephyr when I started tinkering here.
So it's been up and coming for a while. I noticed that people were using it more and more with Nordic's devices before Nordic officially supported it. But it's a Linux Foundation project, and I think they just announced that there's like 20,000 commits, or there's like a crap ton of like people who made contributions to this project. It's amazing. So now it's like a behemoth. It's kind of like Linux for embedded devices, and they do some interesting things with kind of like creating your device and how you interface with it. Like they create it's called the device tree files, where it's like your device definition, and then you basically plug that into whatever code you're running. It's a different concept from maybe like from Nordic's previous SDK, where it's just like you create a header file and you just enter the things you want and maybe it works. And they have like crazy long SDK config files. It was like crazy, but like if you've ever used FreeRTOS, very similar how they configure it. You can do it through like a menu, like a command line menu, or edit it manually in the project files. So, and as like you're scrolling through, yeah, like tons of different boards and hardware. It's crazy, and there's more and more coming every day as people build their hardware. Like the smartphone version of nRF9160 Feather should be in there soon. I don't know if it's there yet, but it just got added recently. So it's just like, if you want to build something with Zephyr, very, 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 very likely you can, especially if it's something like ARM-based. I think there are maybe some RISC boards in there. I'm not 100%
Yeah, they've
sure.
got some RISC boards in there.
Go.
That's so cool. Yeah, they got the Sci5. Yeah, and I saw they have the Zhao from Seed Studio in here. This is amazing. This is a pretty huge list. I had no idea there's this huge community around it. This is impressive.
So the cool thing is like a lot of the
it's
work
easy to get and suck in the spoiled world.
Yeah. The cool thing is a lot of the work is done for you in terms of drivers and things like that. That's kind of like the biggest value add, is you can kind of reuse code for different projects. Like you have an accelerometer. If it's supported by Zephyr, you can move it from one board to the other. You don't have to rewrite things. So it's like one big like hardware abstraction, so, that makes it so much easier.
Yeah, 100%. And um, what are some of the advantages of using this other than like, the standardized code base and things of that sort? Like,
Uh, I mean,
FreeRTOS lets you do like multi-threading and all that, right?
right. And this is very extremely similar. So like I got projects going on right now that are using many, like probably 5 or 6 threads. Um, and some of them you have no control over. Some of them, the ones I added, like I probably added 3 or 4 just so they can run in their own thing. But yeah, it makes kind of running real-time operations a little bit easier, because normally otherwise if you're running a single thread you have to like play nice with everything, whereas this, RTOS will swap in the tasks as needed. So it's a lot of the hard work has been done by a lot of smart people, so it's easier for you. The thing is, it's not like Arduino. It's there's not as many abstractions, so that is a drawback to Zephyr. But I think they have like an Arduino, like plugin kind of thing where you can actually write it in C++ as if you're using Arduino. I haven't played with it, but I know it
wow.
exists, so I know that's very
That would make sense. Yeah.
valuable.
That's super cool. Yeah, gotta love that. Um, what's the most complicated project you've done so far with either Zephyr or the NRF 9160?
So the most complex. So I was picking this up to show you earlier. We were talking about this earlier. So this
Oh
guy
yeah.
is a hub, and what it has inside is it has a bunch of Arduino or Adafruit parts with the Adafruit 7 segment, and it's got a particle xenon that I've totally wiped clean of any particle anything, and it's running some Bluetooth firmware, and actually it's actually running Zephyr, and it's the
Oh,
HDI UART example. So what it does is I can take this guy and put the Bluetooth stack on this guy, and it'll issue commands back and forth between this guy, and it'll act as if it has a Bluetooth device built into it, essentially. So this is like the crazy advantage of using something like Zephyr. What's really exciting is like you can set this up and it just works. It's like somebody did a lot of testing, a lot of development on this HCI protocol, so you can just run it on a separate NCP processor. So this guy is talking to the cloud. I actually have an app that I'm using to basically communicate in real time to separate devices. You can kind of hear those relays clicking in the background to a separate board, which is all connected via Bluetooth as well. So I'm actually issuing commands on an app that goes to this guy. It pushes over to the Bluetooth. The Bluetooth communicates over BLE long range, and then it issues that command to whatever the device on the end. Device does stuff, sends back telemetry data, and all that other things. So by far, this has been a fairly complex project.
oh wow. So if I understood that correctly, you're saying through that HCI protocol, the firmware that you're running on the 9160 just sees the Xenon board as just a Bluetooth through. It just sees its hardware.
Yeah. So it's added in. So when I'm programming the Bluetooth bits, like if I want to do any device discovery, or if I'm wanting to connect to a specific characteristic, scanning, all that definition is happening on the nRF9160 side. So this guy just has a very generic firmware that accepts HCI commands, just like as if like if you plugged it into a Linux machine. I know that stuff works over HCI, where the like BlueZ is all HCI. So it's just a very generic HCI device, and then this guy just knows what to do. It's like I'm going to scan 4 devices with this name, and you just set it in here. It'll talk on, and it'll do its thing over here, and then this guy will just go off and scan and then spit back the results. So
that's
there's
insanely cool.
That is
oh my god. I think back to like all the times I've had to like build out my own firmware just to do something like that, like reuse a piece of hardware from something else, just doing like crazy random serial protocols.
Well, that's what I did
That's
originally, and it was terrible because I had no control
I
over it.
imagine so.
So I was like, all right, I'm going to bite the bullet. I had this working at one point. There were some instabilities about it, but it turns out I was doing something wrong. So I got it working within the past, 2 months. And this thing has been pretty awesome since. It's just like, oh, it's so much easier. Because if I have to make changes to the Bluetooth stuff, the HDI processor can stay the same. And then all I have to do is just update the nRF9160.
That's super cool. I'm excited, and I'm excited to see like what we can do together. So we've been talking a bit, right, about doing some cool stuff with Soracom, and now you can get the nRF9160 with the Soracom SIM.
Yep.
I'm gonna try to pull up what I've got going right now on this thing. Let's see. I gotta just shell into it real quick. Here, I'll share my screen. So and 1152. It's funny. I just assumed it was going to be 115200 because that's always like the standard bot, right?
Yep.
So hopefully I get signal over here. When I was testing this, I was over at our Hackerspace Heatsink Labs. So we'll see if that connects. But so with Soracom, when it's connected, we'll just switch that to my personal account or my work account. So with Soracom, when you have like a SIM created, I don't know if you've had a chance to play around with group settings, but when you create SIM devices or register a SIM, you can then put it in a group and have shared configuration. So we have this service called Storacon Beam, which basically you can connect to it through MQTT, either secure or insecure, because all the credentials, the security is done through the fact that you're connecting through a SIM card that's already authenticated. So you don't have to put any certificates on the device.
That's handy.
So one of the first things I did with that MQTT firmware was I just commented out the TLS part. I said, okay, there's no.
Nice.
Because there's a flag that's the Y. Say that you're using TLS or not. So as opposed to going through that step, I just skipped it, and then in here, you just configure what MQTT broker you want Beam to bridge to. So in this case, I used Adafruit.io. So it's basically bridging the connection. So I didn't have to do much more modification to the sample other than tell it to, I think it's in here, configure it to connect to beam.soracom.io as the broker, because I think originally it was Mosquito. And then, the topics for Adafruit.io, which is like you give it your feed, and I had a couple of topics there. So let's see if it's connected. I might still have trouble connecting because I live in a Faraday cage. Well, when that does connect, it's cool because then I can just see it over on here. I could send it a message with that. I probably won't receive it because it's not connected. But then, gosh, where is it? There's a option to see live feed. So you can see I had some messages come in the other day. So a hello from the MQTT sample.
Oh, nice.
So it just worked out of the box. And that was just through here. So I still haven't decided what I'm going to build exactly with it. I know I'm going to throw the GPS antenna on it and try to make an asset tracker. Because at Adafruit.io, you can make a dashboard with just kind of a map visual.
Yep.
But we can also do that with.
Yeah, you guys are pretty slick. What you call it? Grafana integration, right?
Yeah, so you can create really beautiful dashboards, and we just launched a new version of Soracom Lagoon, our visualization tool. So
nice.
Everything should be a little bit prettier. It's updated with the latest version of all the graphing libraries, and it does a little bit more intelligent stuff. And we've got a blog post that kind of walks through more of that. But
cool.
Yeah, it's exciting. I mean, you take this board that just works out of the box. I don't know which dashboard that is. Oh, I may have not saved these credentials. Let's try that. There we go. But yeah, with something that works so well out of the box,
Right.
and with all the advantages of Zephyr, just being able to create like beautiful dashboards with data, just have all that sensor data. It just possibilities are endless. So my brain's still ticking on like what we can build.
Yeah.
And I know you've built some other cool stuff. I think there was another project you said you had been working on that you wanted to show.
So yeah, the one I showed you, there's the one I showed you earlier was one of the ones I was working on. And then I'm also working on something very similar from an asset tracking perspective. And that's also kind of using a Grafana interface to some extent. I don't know if let me see if I can pull it up. It hasn't been live for a while, so I don't know if it will be showing anything useful. But the idea is to send this guy in the mail or UPS or whatever across the country. Send it over to Hackster headquarters and kind of just see where it's going to end up. So I'm excited to put the finishing touches on that, hopefully within the next week or so, to get that over to them, because it would be very cool to see that, get all that kind of live telemetry going off the device.
Yeah, that's so cool. The other thing I love about this is it's so small. I mean, is that's the case? Yeah.
Yeah, this is the top of the case. So it already
nice.
has the antenna kind of embedded into it. So
that's cool. That's cool.
Yeah, so I printed out the separate pieces. These are all actually, I don't have a fancy 3D printer where I can do multiple colors, so these are all glued in. But it's just kind of a circular puck. It's like their logo. So kind of cool.
Nice. Yeah, it's that's the other thing I've been excited to see. Like I'm really hoping that people use this device as an opportunity to experiment with cellular wearables, because in other devices I've used, they tend to consume a lot more power, or they're just larger profile. Whereas
Right.
I mean you look at the chip itself is just so tiny.
Right.
And it seems to run fine off of just USB power. No need for a battery or anything of that sort.
Yeah.
So I mean,
from an extended, like this guy, let me see, I can show you the other end of it, but I'm using, let me see if I can find the board. I don't have the board, but you can imagine the board, it's just another circle, and it has a CR123 battery on it. And then on the other side, it just has the nRF9160 feather. And that will last, if you get it right, that'll last like a crazy amount of time.
Oh, wow. Yeah, I think you have it on your website here. I'll share that again. This one, right?
Yeah, so that's this guy. And that's one of the first enclosures that I built. And that's an 18650 battery. So I offer that for sale, and with that's part of the sales page there. But it takes the nRF9160 feather. You just pop in the antenna, and then you got the battery, and you're off to the races. And you can just kind of stick this in your car and just forget about it, because the battery is going to last a long time.
Yeah, it's just I remember back to I know people who were dealing with acid trackers a couple years back, like mil-spec acid trackers would cost something like $5,000. Just absurd amounts, because like the idea was they would last a long time. And that's what you get for when you pay for mil-spec, right? You're actually paying for someone to tell you it's going to last a while. But I think just with this, you could throw together equivalent, if not better, product,
right?
For $100. So
yeah, you can't really, with this board, you're not going to be able to put it in like an oven and have it run correctly.
No.
But like if you have it in your car, kind of normal temperatures for that, as long as you're human and you can survive in it, the tracker will work fine.
Are there any projects you've seen out in the wild using this that you're excited about, or that kind of sparked your interest?
Let's see what is going on. So very early on, during like the launch campaign, there were some guys who do storm tracking, and they actually took the design and assembled it themselves, which is a-okay, fine with me, because it's just really cool to see. But they were putting them into devices that they would throw into hurricanes or tornadoes or something like that to collect data about the storm. And I was like, really? This is cool. Like,
that was the plot to Twister.
yeah, exactly. So that was like one of the very early on, like, whoa, this is crazy. And like the more I build things like this, and like the air quality board I built previously, it's just like people reach out and they're like, thank you for making this board. Like we're strapping it to cars and checking the air quality of the airport in England. It's like, what? I was not expecting that. It's really cool to see. It's just like everybody has a million ideas, and I can only do so much. So it's very cool to see other people make it, bring it to life.
That's rad. And that's, earlier before we started the stream, we were talking about how like the CNC that you have behind you, the person who built that and who unfortunately has passed, like their legacy of open source, right? It's when you put something like this out there,
Yeah.
it lives beyond you, and it takes its own life, right? And I think that's one of the advantages of open source, on top of like there's a lot of good business cases for doing it, and there's a lot of like technical good for it. But I think it's a form of digital immortality in a sense, and like an extension of like ideas that we can have, right? Because I mean, my projects over the years, they're only as good as the open source community.
Right.
I wouldn't have been able to make any of this, and like we wouldn't have been able to build any of these tools that we build and use. Like even like looking at Zephyr, right? That's because of the open source community. That's why it's grown so much.
Right.
I think what you're doing is awesome. It's adding to that kind of like collective goodwill that makes it so we can all be creative.
Yeah, it's very exciting to be building stuff like this because, there are people out there who make closed source. Like I've built a lot of products over these past, 10, 15 years of doing this professionally. And it's sad to see that some of that stuff never sees the day, light of day. And it would be great to not have to rebuild the same thing over and over again. So that's part of why I do this, is like I'm doing a lot of stuff. I'm basically like I'm coding a backend in Rust right now for IoT devices, just because I'm just tired of building the same thing over and over again. And the same thing with the hardware. It's like, why like this doesn't exist? Why not make it useful for people? So it's definitely been useful for people for sure.
Oh man, yeah, that's the right spirit for it. I think that's one of the other main things I love about this product is, I mean, it's makers in mind, right? And it's that concept. So I know earlier we said only like we'll just do like a short chat, a couple minutes or half an hour, but now I've been asking a lot of questions, and there's things that you want to ask me, or there's things that you want to talk about. I know like you do a lot of cool stuff. It seems like you're a maker of all kinds.
I try. A lot of it's been like working on things that help help folks like you, my customers, build stuff faster, where they don't have to get bogged down by all the details. So that's where I've been focusing a lot lately on. Is mostly also like the projects, like the little hub I showed you earlier. That is all, like half of that is all stuff that I've done on my own. So other people can kind of take the torch and just keep going. And plus I just didn't want to do it again. So half of it's closed source, half of it's open source, which is very cool. And to work with people who understand that, which are okay with it. I mean, they save a lot of money just for the fact that I'm not billing them hours for some of the parts that are open source. And then, people benefit from it down the line. So, yeah, I'm always, unfortunately, like when I get the chance, like taking a step back, like I love to think about like things that I can build to, kind of help people out a lot. But now it's just like I'm so deep into like making sure this thing works for folks. So it's kind of like that interesting balance I gotta I'm like on a tightrope kind of thing.
That's fair enough. If I always like asking this question, as this is how I would introduce people when they would walk into a hackerspace, is if you can make anything, sky's the limit, whether it's beyond your skill set or maybe what's reality. If you could build anything,
Oh
like
man.
like passion project.
Oh man. That's a good question. So for like some type of like crazy industrial machine to like make something that I love. Like I was just thinking the other day, so I included a little package of something sometimes when people buy stuff from me directly, and I was like, what if I could just like make my own gummy bear? So what if I could just like make my own gummy bear machine? Or I'm into bread making, so it's just like, what if I just make a machine that will just like do all the hard stuff for me? Because it's all sourdough, so sourdough takes a while, and you have to do certain things at certain times to kind of do it right. So it's like that's something interesting. Though I mean, those are like, I guess, smaller scale projects kind of thing. Something bigger though, oh man.
I think that's a cool, like a sourdough IoT, just something to monitor.
Right.
Because there's a lot of involved process there, I think, right?
Right. And actually there is a very cool product. I'd have to remember the name, but attending the open source hardware conference, there's an individual there that he had actually prototyped and he was like crowdfunding his sourdough starter, like mason jar lid. So
that's cool.
They're doing like he's doing tracking of like when it is the exact time that you can use your sourdough starter. And it's like, what's the rate of rise, and like,
nice.
How much like CO2 is created. It's very cool.
That's rad. It's actually there's this sensor I got from Pi Moroni. I don't know if that's focusing or not, but it goes on their breakout garden. It's the BME688, and from what I understand, there's something where you can load on these special profiles to make it sense different types of gases. So it's like a multi-purpose gas sensor. So you can have it sense like just a myriad of list of different chemicals, as opposed to just like something that's hard-coded CO2. So I wonder if that could be used for something of that sort. Oh, seems to have frozen, Jared. I'm not removing, bring him back. You still there? Oh no. We'll give Jared a second to come back. All right. One moment. Technical difficulties.
I'm back.
Are you back?
I don't know what happened.
Oh, cool. Awesome.
So you're saying the BME 680 whatever by Bosch.
688, yeah.
That's like the new one, right?
I think so, yeah. And it's you can put different gas profiles on it to detect different gases from one sensor. So that's something to think about. Like when you have all these new sensors, plus when you add in things like, easy to make AI edge models with like something like Edge Impulse. I imagine you could kind of put 2 and 2 together and figure out how to, make a sourdough smarter on the fly. But I'm also probably more interested in the gummy bears thing. I years ago tried to do that with the 3D printed mold, but didn't think through the part where my printer at the time wasn't great, so the ridges were really strong, so it just got stuck. I just ended up with a piece of plastic filled with gummy. I was also in college, wasn't thinking it through.
Yeah.
But yeah, I'd love to see something like that, just a IoT gummy bear or just a gummy bear printer.
Yeah. Hey, the future's ahead of us. We just got to make it happen, right?
Exactly. Or it's where Gibson's like the future's here, but it's not evenly distributed.
Yeah.
It's just not open source enough yet.
Mm-hmm.
Well, right on, man. This has been great. This is a great conversation, and I'm excited.
Likewise.
I know we plan to come back and do another kind of live stream event in the next couple of weeks. which is, we'll talk more about that later.
Uh-huh.
But yeah, thank you. And if there's any closing thoughts you have, please share.
The only closing thought I have is like, if people are interested in using Soracom on the nRF9160 Feather, you can get it. Actually, let's see, on jaredwolff.com, if you, in the top right corner, there's a link for the nRF9160 Feather that goes right to the store page. And for folks who are watching this live stream, there is a code you can put in and get 10% off. It's Soracom 10. So for folks who are interested, get 10% off, and for folks in the US, you can get it for free, or the shipping for free. So a little less cost if you get it anywhere else. So there you
Yeah. All right. Well, thanks, Jared, for joining us. And thank you, everybody who's watched. Again, Jared's website's jaredwolff.com, 2 Fs. And again, my name is Mohib Zara. I'm a developer evangelist with Soracom. You can find me at VirgilVox on Twitter, and hit me about any questions, any projects, anything you think we should know about or get involved with. Would love to hear from the community. And thank you, Jared, and thank you for watching, everybody. And with that, we'll sign off the stream.